Okay, we're now recording. Give me a moment to share the screen as usual. Okay. Yes, a lot of repetition. Sorry, but I think it's necessary to make sure nobody has any excuse for not knowing the rules. Okay, so I'm already done with 1.5. So coverage of the exam will be stuff from here. I usually give about 10 questions. You've already submitted a couple of quizzes, so now you know how I want you to submit the homework and the tests, pretty much the same way. So you're responsible for this. 70% homework requirement. You must submit at least 70%. I mean, there's no reason for you not to submit 100%. I mean, you should, but in case something goes wrong or you've missed out on a couple of problems, that's why I say 70%. And what do I end up doing in class, right? I end up doing half or a little bit more than half, a little bit less than half. So it's not that hard to fulfill the 70%. So if you don't submit 70% of the homework, I don't grade your test. It's a 0. Okay. And so I will lecture on 2.1 today, maybe even 2.2. Tomorrow, as I said, I'm going to dedicate the whole time. In other words, I'll let you have the whole time to ask me questions from here. Okay, so if we take the entire class period for questions and answers, that's fine by me. So no questions and answers on Friday. Friday will just be the test. You get the entire time for the test. Slightly after 9 o'clock, I'll send by Canvas announcements the exam, and then just come on and join as usual. You won't hear me call the row. I'll just, I have the whole class period. I got plenty of time to check the attendance. And then as usual, and the only time where I absolutely insist on your camera being on and your true background is during exams. Okay, so you must have your camera on, otherwise how do I know who's taking the test behind you, right? So during the test, keep yourself muted. If you have a question, put it in the chat. Again, just think of the equivalent of we were meeting face-to-face. If we were meeting face-to-face, I wouldn't want you to just blur it out. Hey, I have a question about number 7 or whatever. You would come talk to me silently about it. So the equivalent is you shouldn't unmute yourself during the test and interrupt everyone else. Just put the question in the chat and hopefully, I'll get it and answer you in time. Okay, so you have to have your actual camera and the true background. Don't have like Golden Gate Bridge or whatever. I need to see who's behind you also for the exam. If you finish early, you can leave early. Okay, so let's see. Slightly after 9 o'clock, I'll send the test. You join as usual. You won't hear me call the row. I'll just look at the participant list. And then class ends at 10 o'clock. So by the way, show all your work, just like we did all the homework and so forth. Show all your work. And then when you're done, just take a picture, click, 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 just like the quizzes, and email it to me. Same email address as the quiz. And then I'll give you until half an hour later. So what, 10:30? Let's say 10:30, you have to submit the homework. But if you want to submit the homework early, so how about I'll take the homework anytime after class Thursday. So when Thursday's class is over, I'll take the homework right after class, anytime up until Friday at 10:30. You can submit the homework. And a warning, I'm not sure all the homework will fit in one file. I have had students before that tried to load all of this and then something said, can't do it, not enough memory or not enough space or whatever. So you can break it up into pieces. Like you do one section for each email. Email me for 1.1, another one for 1.2, another one for 1.3, and so on. Or maybe you can fit 1.1 to 1.3 in one email and 1.4 to 1.5 in another email. That should work. Now my computer is a school computer. It's not top of the line. I cannot access all types of files. Okay. If you send me PDF, that should be fine. But some of you do some fancy stuff that I don't even know what it is, that you do some zipping, unzipping, or have some other format that I'm not sure I can get. Google Docs, I'm not sure I can get. Okay. So I will say this, you've all submitted quizzes that work. So if you submit quizzes, however you sent the quiz, if you do likewise for the homework, that should work, right? Okay, if you do this, it just might take a little bit longer because of file restrictions and stuff like that. Okay, so again, how do I study? Study off of this. Again, you get one cheat sheet. So one 8.5 by 11 sheet of paper, you can write on the front and in the back, and you can use a calculator, but after that, you're not supposed to use anything else. So no books, no notes, no people, no internet, no computer. You know, the rest you have to work on your own. Okay. All right. So that's general rules about that. And let's see. I think that's about all I want to say about that. So any other questions before I get started from the homework, the exam, and so forth? Okay, you can put it right now, but if you have any questions, then ask me now. Okay, I don't see or hear anything, so we'll just go ahead and get started. Okay, so again, I'm starting 2.1. You can take notes, but kind of look at it half-heartedly. You should not study this material until after the test. Okay, all right, so we're actually getting into the calculus now. And again, for those of you who have calculus background, don't use any shortcuts. Okay, pretend, if that's even possible, pretend you never had calculus, if there is such a thing, and go from there. Okay. So I will now develop some of these homework problems that we have. 2.1. So quick review of where we were talking about. We had secant lines and tangent lines, right? Secant lines are the blue lines, page 79. The tangent line, which never changes, is the red line, okay? And if I fix the point P, P is the same, all of these. Q moves closer and closer on the right side over here, and Q moves closer and closer on the left side. As Q moves closer to P, the blue lines and the red lines look closer and closer. So you can think of the tangent line as a limiting line. What line do we approach as point P gets really, really close to point Q? Okay. All right, so yesterday I talked about these and what you were supposed to do. I'll actually go ahead and do them now. Okay, now A says find the slopes and so on, and B, estimate the slopes by averaging the slope of two secant lines. Okay, so the most accurate I mentioned last time was to pick the two that were closest to 15, namely 10 and 20. Okay, so let me work on that right now. So your P, so-called, the fixed point was 15, 250. So number 1, A, 15, 250. And they give you the choices of 5, 10, 20, 25, and 30. I will just show you 10 right now. So we had 10, what? 444. I guess it is. All right, so find the slope. y2 minus y1 divided by x2 minus x1. Okay, so 250 minus 444 divided by 15 minus 10. Punch it in your calculator. So negative 194 over 5, which is something. Where's my calculator here? I think it's negative 38.8. Negative 38.8. Okay, then do the same thing. You still have a fixed point of 15 to 50. And the other one closer to it is 20 something. 20, 111. Oh yeah, and the units, well, it's change in Y divided by change in X. So that would be gallons per minute. So this one, y2 minus y1 divided by x2 minus x1. So how about 111 minus 250 divided by 20 minus 15? So that's going to be negative 139 over 5. And what does that come out to be? Negative 27.8 gallons per minute. Okay, so what have I done? I've done it for 10 and 20. Okay, so I've done these two. So I'll let you do 5, 25, and 30. Okay, it's just slope, and you already know how to do that. Okay, B, estimate the slope of the tangent line by averaging the slopes of two secant lines. So I'll just average these two. So average is add them up and divide by 2. So negative 38.8 plus negative 27.8 divided by 2. So 38.8, 27.8, negative 33.3. Gallons per minute. All right, and you may notice, by the way, these are not supposed to be the same. So we said at the start, okay, this thing's draining faster than later on. So at time t equals 10, it's draining at 38.8 gallons per minute. Then later on at time t equals 20, it's draining only at 27.8 gallons per minute. It slows down, as we might guess. Okay, so our estimate for the slope of the tangent line is negative 33.3 gallons per minute. So right when I'm at 15 minutes, which I guess is halfway, right? Halfway from 0 to 30. Okay, what's the rate at which the water is draining? 33.3 gallons per minute. Okay. Okay, and then for part C, I'll show that to you again for focusing purposes. And raise it up. C, use a graph of the function to estimate the slope of the tangent line at P. This slope represents the rate at which the water is flowing from the tank after 15 minutes. Okay, so that's where I go like this. All right, so I showed you this red graph. And where does the red graph come from? That's just plotting all of these points that I mentioned yesterday, right? So 5, 694, 10, 444. And by the way, 0, 1000 also. Blah, 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 all the way down to 30, 0. I plotted all those points. And I ended up with the red graph. Here's 0, 1000, right? All the way down to 30, 0. So I just connect them with a smooth curve. Now, I drew myself a tangent line. Okay, so I went like this. And by the way, this is guesstimating. So your graph may not be exactly the same as mine. That's okay. That's not an issue. That's to be understood when you have pictures like this. That's the best we can do. All right, so I just went like that. I need to find a slope. Okay, so find a slope. What did I do? I just picked some convenient point like here. Okay, I got 15,250 already. And so when I go like that, that seems to be the point 0, 700. Okay, so I just kind of eyeballed it. Okay, just barely graze it. And so I do the same thing with 15, 250 and 0, 700. Let me raise it up again. So M tan, slope of the tangent line, is y2 minus y1 divided by x2 minus x1. So that would be 250 minus 700. 250 minus 700 divided by 15 minus nothing, which is negative 450 over 15, negative 30 gallons per minute. Okay. So right smack dab at time t equals 15 minutes, how fast is it draining? It's draining at the speed of 30 gallons per minute, which is indicated by the negative. Okay. That's what I got from the picture. And a side note, what did I get for the earlier part was negative 33.3, so pretty close, negative 30. negative 33. You're not expecting it to be entirely accurate because this is all guesstimating, right? It's not very accurate. We're just drawing a curve. Your curve might be a little bit different than mine. So if you were given something like this on a quiz or test and you're anywhere in a ballpark, I would give it to you. Okay. Okay, let me set you up with number 3. The point 2, negative 1 lies on a curve of y equals 1 over 1 minus x. If q is a point x comma 1 over 1 minus x, use your calculator to find the slope of the secant line PQ, correct the 6 decimal places all the following values of x. So it's a lot of number crunching, but you're still doing a lot of slope. Okay. So what's happening? 1.5, 1.9, 1.99, 1.999. You're getting very close to 2 coming from the left side. 2.5, 2.1, 2.01, 2.001. You're getting very close to 2 coming from the right side. Okay. Another way to think of it is the first 4, 1, 2, 3, 4. You're kind of like this picture. You're kind of like the bottom there. Q approaches P from the left. And then the other numbers, you're approaching from the right. You're getting close to 2 on the right side. So if we look at the numbers that they give us, so your fixed point is x equals 2. And look at these first 4 numbers, 1.5, 1.9, 1.99, 1.999. You're getting real close to 2 coming from the left side. And then how about 2.5, 2.1, 2.01, 2.001? You're getting real close to 2 coming from the right side. Now, these are all x coordinates. You plug in to find the y coordinate, and then do your y2 minus y1 divided by x2 minus x1 again. Okay. There's 8 of them. I'm not going to do all 8. I'll just show you a couple, just enough so you can see what's going on. Okay. All right, so y equals 1 over 1 minus x, 2 comma negative 1. I decided to pick Roman numeral 4 and Roman numeral 8, 1.999 and 2.001, the 2 closest ones. Okay. So number 4, 1.999, 2.001, and also believing those 2 would probably be the most accurate, right? So I'll do 1.999, number 4, 2.001, number 8, and you do the rest. Okay, so you do 1, 2, and 3, 1.5, 1.9, 1.99, and what, 5, 6, 7, 2.5, 2.1, 2.01. All right, so 1.999 gives me 1.999 comma negative 1.001001. You just plug right in, and that's what you get, the function value. Okay, and maybe I'll show that to you. So y equals 1 divided by parentheses 1 minus 1.999. Okay, so 1 over 1 minus that. 1 over 1 minus 1.999. Negative 1.001010. So it looks like it repeats 001s. Oh yeah, and divided by 1.999 minus 2. So 1.001 repeating. Bar means repeating. All right, do the same thing for number 8, 2.001. So 2.001 comma that. So the y coordinate, you plug in here again. So 1 divided by parentheses 1 minus 2.001. And yeah, we're supposed to divide it by, I didn't show you the denominator, sorry about that. So let me show you that right now. divided by 0.001. So it's 0.999000. Repeating. Okay. Sorry, I messed up here, but it's like that. And then if you divide it by negative 0.001, you end up with this. So 0.999000. So it's 999,000, 999,000, and so on. Okay, so look at that number. 1.001, 001, 001. 0.999,000, 999,000. Guess the slope of the tangent line. What's a very nice, convenient number nearby? 1. Which means I'm going to say the slope of the tangent line is 1. So that's part B. Let's see where to go. Use the result of part A to guess the value of the slope of the tangent line to the curve at 2, -1, and then find the equation of the tangent line, blah, 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 blah. Okay. So the two closest values, this one and this one for the slope, they're both real close to 1. So I'm going to say the slope is 1, slope of the tangent line. And then for the equation, we're going to write it in point slope form. Get used to the point slope form. Some of you have not been doing point slope form maybe that much. Quite often I'll have you leave the answer in this form. So y minus y1, y minus a -1 equals m times x minus 2. And unless otherwise stated, you can stop here. Okay. So once you give it to me in point slope form, you can stop. In your earlier algebra class, you may have had your algebra teacher say, give it to me in y equals mx plus b form, which is perfectly fine. You know how to do that. I'm saving us some time and energy. Just put it in a point slope form and just stop and you're done. Okay. All right, and then question number 5. Okay, so we only had to do 1 to 7. 5, you kind of do the same thing. A ball is thrown into the air with a velocity of 40 feet per second. Its height is given by y equals 40t minus 16t squared. A, find the average velocity for the time period beginning when t equals 2 and lasting 0.5 seconds, 0.1 seconds, 0.05 seconds, 0.01 seconds. Okay, lasting, that means you go from 2 to 2.5. Here you go from 2 to 2.1, 2 to 2.05, 2 to 2.01. Okay, so I'm going to write that down for you right now. So just a hint for number 5. Y equals 40t minus 16t squared. So your fixed number is t equals 2. Let's see, what do you get when you plug in 2? Let's see, 80 minus 64, 16, I believe. Okay. Lasting 0.5 seconds means you go out to t equals 2.5. Lasting 0.1 seconds, you go to 2.1. Number 3, lasting 0.05 seconds, plug in 2.05. And finally, lasting 0.01 seconds, you go to 2.01. Okay. And then you plug them in. Okay, why don't I just do the last one? So let me punch it in the calculator now. So 40 times 2.01 minus 16 times 2.01 squared, 15.7584, and you do the rest of them. Okay, so 40 times 2.01, 40 times 2.01, minus 16 times 2.01 squared, 40 times 2.01 minus 16 times 2.01 squared, 15.7584. And there's a calculation for 2, 40 times 2 minus 16 times 4. Okay, so average velocity. Well, 16 minus 15.7584, y2 minus y1, divided by x2 minus x1. 2 minus 2.01. Okay, again, in case you're wondering from algebra, do I subtract this way or do I subtract this way? It doesn't matter. Either point can be designated as first point or second point. Okay, and what does that come out to be? Work that out quickly. Negative 24.16. And you can give units. Okay, now we're given feet and seconds. Feet and seconds. So delta y over delta t, feet per second. It's a velocity. Okay. So when I do the slope of the secant line or slope of the tangent line, right? Slope of the secant line is average velocity. Slope of the tangent line, instantaneous velocity. So the average velocity, negative 24.16 feet per second. So what would be a good estimate for the instantaneous velocity? Well, the number that's nearby would be negative 24. Negative 24 feet per second. Okay. So we can get the instantaneous velocity if I take the average velocity of 2 points that are really close to each other from that picture, right? So these are quote unquote really close to each other, 2 and 2.01. If you want a greater accuracy, I can go from 2 to 2.001 and 2 to 2.00001, right? And get even more and more accurate. But for now, we'll just go with this, negative 24 feet per second. Okay, then I have number 7, then I'd be pretty much done. Let me check the chat, what you have here. Do you choose those specific points for average velocity? Well, we're just going by whatever they told us to. So it said start at 2, and if it says lasting 0.01 seconds, that means you go from 2 to 2.01. Lasting 0.5 means you go from 2 to 2.5. So that's why I have this chart. So you figure this out, and this is how you do it. Okay. Okay, it can be just any point. Well, yes and no. They told us specifically to use these points. Okay, so yeah, I could have picked your what, 2.2, 2.001, 2.001. Right, that would get really, really accurate, right? Because then those 2 points are really, really close. So that would probably be the most accurate. Okay. All right. Okay, then 7, and then we're done. Find the average velocity for each time period. Okay, you should know what to do, right? From 2 to 4. So 2 comma 20.6, 4 comma 79.2, do y2 minus y1 divided by x2 minus x1. Okay, in this case, it'll be delta s divided by delta t. Okay, So you just read it off the chart. So for instance, I think I'll just do one of them. So 7AI says go from 2 to 4, right? So if I do this one, you do the same thing for that one, and that one, and that one, right? Okay, so it's 2 comma 20.6. And 4 comma, right? 4 comma 79.2. Okay, so yeah, what are we doing? Position of a motorcycle after accelerating from rest. Okay, so the motorcycle starts at 0, obviously, and then it starts to speed up, I guess, right? So 4.9, 20%. So after so many seconds, this is how many feet it's traveled. So average velocity, right? Distance divided by time, delta S over delta T. So delta S over delta T, okay, this is time S, that's just like X and Y. Okay, again, we don't use D for distance. We use S. D is going to stand for derivative later. Okay, so 79.2 minus 20.6, all divided by 4 minus 2. Okay, punch it in the machine. 79.2 minus 20.6. 58.6 divided by 4 minus 2 is 2. So 29.3. Okay, the units of this are in feet. These are seconds. So we're getting feet per second. Right? Do the same thing for the other ones. So you do that and that. And then again, my recommendation is I say do it. Don't do it until after the test. You're focusing on the test. So again, for now, just put it down. We're just getting ahead and study it after the test on Friday, right? Use the graph of S as a function of t to estimate the instantaneous velocity when t equals 3. Okay. So we just plot all the points. Okay. So what is this thing here? So time in seconds, distance S in feet. So I do delta Y divided by delta X, or delta S, change in distance divided by time, it would be what divided by what? Feet divided by second, which is feet per second. Okay, now where am I getting all these dots from? I just simply plotted all of these. This is a first quadrant view, right? I don't do the normal X versus Y. I don't have to, right? Everything's positive. So just first quadrant. Okay, so 0, 1, 2, 3, 4, 5, 6. How come? That's all they gave me. And the highest I went over here, I guess, was 180. Right? So 0, 1, 2, 3, 4, 5, 6. That's all I went. And yeah, I went up to 180 because the biggest number they gave me was 176.7. So I plot 0, 0, 1, 4.9, 2, 20.6, etc., all the way to 6, 176.7. Of course, it's not going to be that accurate when I draw it. And there it is. All right, and yes, we're just guesstimating, just doing an estimate there. Okay, so it says estimate the slope of the tangent line, which means instantaneous velocity. Let's see where to go. Instantaneous velocity at time t equals 3. So I already have 3, 46.5. That's for sure. So what about the second point? I drew myself a tangent line and I just guessed another point. And if you were to do this, you may not get the exact same value as I do, but that's okay. So a nice point is where it touches the t-axis. So that looked to me like roughly 1.8. So I called it 1.8, 0. All right. So M tangent, that says M tan, M of the tangent line, slope of the tangent line. So y2 minus y1, 46.5 minus 0 divided by 3 minus 1.8. Where did I get to 1.8? I just read it off the graph. It looked like it's, you know, kind of close to 2, but more than halfway, so 1.8. That's a 1 there. All right, so that comes up to be 46.5 divided by 1.2. Punch in a calculator, 38.75 feet per second. And that is that. All right, folks, I'm actually done, okay? And in fact, I'm done with 2.1 in terms of keeping up with the schedule or getting ahead. So originally, I wasn't going to do 2.1 until Monday and even some of Tuesday. I'm done with it, okay? Which means I'm on track to even start 2.2. But again, I was going to leave you 2.2 for tomorrow, okay? So 2.2, where are we headed? Now, if you spend the whole time tomorrow asking me questions, we won't get to this until Monday, but that's fine. Okay. So we're doing something called the limit of a function in 2.2. And it looks like we got some super long tables. You say, oh, do I have to make this table? Not often. Okay. At the beginning, you might, but later on, you won't have to do it that much. Okay. Have something called a limit. Okay. On page 83, we have this strange new terminology. Don't worry about it now, okay, but you're going to get used to something weird looking like this. Limit, L-I-M, lim, x arrow a, which stands for x approaches a, of f of x equals L. Okay, so I'll teach you all that next time, but or even tomorrow if you don't ask me questions tomorrow. Okay, so we'll learn about limits. We'll analyze graphs involving limits. Okay, so page 84, see where it says limit, figure 2, limit x approaches a, that arrow says approaches, limit x approaches a of f of x equals L in all 3 cases. So that means in all of these cases, slightly different, you have the same limit. They make a table. We already did that in section 1, right? It looks like we're getting real close to 1 on the left, 0.5, 0.9, 0.99, 0.999, 0.9999, okay? And then the bottom table, you're approaching 1 coming from the right, 1.5, 1.1, 1.01, 1.001, 1.001, right? They plug in the function value and see what we approach. Okay, it looks like we're approaching a half, right? So on the top, it gets to 0.500025, and the bottom is 0.499975, getting very close to a half. Okay, so we'll be doing some of that. I'm not going to do that much with graphing because you're not required to have a graphing calculator for me. So I will barely touch any of that stuff. Okay, so we'll be doing something called limits. So we'll look at the language that we'll have, limit as x approaches 0 of some function or whatever. Okay. You don't have to take notes really now. I'm just giving you a heads up. Page 87, something called one-sided limits, whatever that means. Okay. There's also something called two-sided limits, one-sided and two-sided limits. And infinite limits, limits going to infinity. You see from this table, it just gets bigger and bigger and bigger, right? Blows up. So we would say we approach infinity. Okay. All right, so that's what's going to happen. So that's going to happen tomorrow if you don't ask questions, but I'm letting you ask questions all of tomorrow in preparation for the test. So, so again, we are here. I guess I can already knock off 2.1 in the schedule, so I'm a little bit ahead. It's good to be ahead in case I fall behind, I get sick, my internet goes down like last semester or whatever. That's where I'm at. Okay, so I'm done. I wasn't going to give you an in-class assignment today on 2.1 because I don't want you focusing your brain on 2.1. I want you focusing on all this. Okay, so again, so tomorrow when you come in, I'll let you ask questions here the whole time, but if that stops, I'll just do some more 2.2 stuff. And then Friday will be our test. Okay. All right, so that being the case, I am done today. So if anybody wants to ask a question right now, you can put it in the chat, or unmute yourselves. Otherwise, we're just going to stop. Okay, so anybody have any questions, please, about what's happening and so forth, how the test works? The homework requirement, you're supposed to submit at least 70% of the homework. If you don't turn in the homework, I don't grade your test. Okay, and I don't see anything and I don't hear anything, which means we're done, folks. All right, so tomorrow, question and answer, ask me anything. Otherwise, I'll go on to do more chapter 2 and the test is on Friday. All right, okay, that'll do it for today, folks. So we'll see you next time. Okay, bye.
All right. See you.
Thank you.
Thank you.
Thank you.
Professor, excuse me. How many points will be the exam?
Exams are 100 points
Okay.
out of 100. Okay. Let's see, Ramir, Khan Academy, if you want to use Khan Academy, that's fine. The stuff that they do there may not relate to what we have. So I think it's better just to focus on what I gave you. Okay. Because the problems I'm going to give you are just like that. And that's not necessarily going to be true for Khan Academy. So just focus on the problems that we have here. And by the way, check with Prasanna. Prasanna might give you some good stuff too. Okay.
Thank you, Professor.
All right. You're welcome.
I just wanted to check in with you really quickly. I just saw your email, but I'm still taking the test right after class tomorrow.
Right.
That's
So we're
good.
good for
Okay.
that.
Yeah, I
So
just wanted
that-
to check in.
Yeah, we're all agreed on that. And so just join the session. So if I'm talking to somebody else, then, turn my volume down so I don't interrupt you. And
Mhm.
who knows, maybe I'm giving away some answers if you have your volume on. But a lot of times nobody comes during office hours, in which case, everything should be fine. Okay.
Okay, sounds good.
Right.
Thank you.
That's good. All right. Thank you, Charlotte. Okay.
Bye.
Bye. See you.